Good morning, geometry students. We're doing section 4.7 today. When you take notes watching a video, remember you can pause, rewind, and use those features to help you take the best notes as possible. We're going to start with a warm-up. Pause this video, go ahead and try the warm-up, and then we'll go over it in just a second. All right, so hopefully you were able to work through this. First thing we have to look at, what's the given information and how can we use that? And we have to go through our proofs of the 5 methods that we learned the other day. First thing we're going to look at is CT is parallel to AB. Okay, notice how I'm adding the information to my drawing. Now keep in mind, just because they're parallel does not mean that they're congruent. We need another statement, the second one, CT is congruent to BA. So then I can use the markings, and now I know they're both parallel and congruent. So I'm going to go ahead and just use the first piece of parallel lines to see what conclusions can I make about the two triangles based off of parallel lines alone. So first thing is I have CTA. Notice this makes a Z, and it creates congruent interior angles between the parallel lines and the transversal. So alternate interior angles shows that these two angles are congruent. And then we have a pair of congruent sides already from the given. So if I think of it, I was able to conclude I have a pair of angles from the parallel lines, and then I have a pair of sides congruent. So I already have a side and an angle. And that's it from the given information. But we do notice that the two triangles share a common side, and that's called the reflexive property. We'll learn that much later. But that shows us we have another pair of sides that are congruent. So if I'm going through my thought process and thinking, what do we already know? Side, 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 angle, hypotenuse, leg, angle, side, angle, and angle, angle, side. So I'm going to kind of go through a process of elimination. I don't know anything about the angles being right angles, so it definitely cannot be HL. I don't know anything about CA being congruent to TB. There's no conclusions that can be made, so we can't do side, side, side. And I had an angle and a side. That really gave me 3 choices to choose from. But then I noticed I had the reflexive property, which gave me that extra pair of sides. So I have 2 sides and an angle, which basically reduces out all other pieces, and it leaves me with side, angle, side. And you can kind of see that here. Sometimes students like to just put, here's a side, the included angle, and another side. So side, angle, side, and that matches perfectly with the other triangle, side, angle, side. So identify the reason the triangles are congruent by side, angle, side, and maybe I'll write my statement up here. Well, what triangles are congruent? Let's call it triangle CAT. I get to just pick the first triangle, and then I have to map it. So I went from C to A to T. Well, let's think about what corresponds with angle C. C is made up of the side length we don't know anything about and the 1 tick mark, the parallel line side. So I'm going to find the same matching. Here's the side we don't know anything about, and the 1 tick mark, C matches with B. So I have to start at B. And then I went from C to A. So I followed C to A. I traveled along the side I didn't know anything about, and I ended up with the angle that I didn't know anything about. Well, what matches that on the other triangle? From B to T. So the next variable, or the next letter, would be B. And then I went CAT. So A to T travels down the 2 tick mark side, and then what would be the same path? B went to T, and then T would have to finish at A. So the triangles are congruent by side, side, side. Now, quick little addition. What else do we know? Since I just have shown that these two triangles have to be congruent, and I know that I have a side, an angle, and a side congruent, don't we know that everything else is congruent? And that was kind of how we introduced congruent triangles. But what that means is I could actually ask you to prove something different. What if I asked you to prove that angle C was congruent to angle B? Well, the nice thing is you wouldn't change anything that you did here. You would still prove the triangles are congruent by side angle side, and then you would make just an extra statement, and we'll get into that much later. I just want to, since we have this, we could take advantage of this opportunity to say, well, wait a minute, what else do we know? CAT, angle CAT is congruent to, now you can read your statement as well. Notice CAT has to be the same as BTA, or you can read your triangle. BTA, this angle down here, has to be the same as this one if the triangles are congruent by side angle side. And then we know one more conclusion, the two side lengths that we don't know anything about, CA is congruent to, and look at, I could even read my statement. CA has to match with BT. And the reason why this is true is once the triangles are congruent by one of our 5 methods, then their corresponding parts of congruent triangles are also congruent. So that's a little side note. All right, 4.7 is the title of the notes. We're going to explore isosceles and equilateral triangles. The essential question is, what are the properties of isosceles and equilateral triangles? I put this on here just to remind you, if you take Cornell notes, that's a great way to organize your notes and kind of help create study guides as you go along. You can write essential questions or left-handed questions on the side here as we learn notes, and then you can refer back to these. I'm no way going to require Cornell notes. I'm going to encourage it though. All right, let's look at some vocab. Isosceles triangle, we defined that the other day. It has to have at least 2 congruent sides. So let's just pick the TH and ST to be our 2 congruent sides. Then we have to have a vertex angle. A vertex angle is the angle that's formed between the 2 congruent sides. Angle H. That's the angle that's formed between the 2 sides. Now, the legs of the isosceles triangles are the congruent sides. So those are the 2 sides that are equal. That's TH, and side length SH. And then base, we have to be careful. Base does not always mean bottom, right? We have to kind of get rid of that terminology. In this case, the base is the opposite side from the vertex angle. So remember, I can flip this triangle any way I want to, but opposite side length of the vertex angle is TS. And then one of the important things about an isosceles triangle that we're going to learn here is something called the base angles. Those are the angles that are formed on the base. So we would say angle T and angle S. Again, you can pause this if you need more time to copy everything down. But there's a special theorem about the base angles that we want to look at. Base angles in an isosceles triangle are congruent. So look at this picture and how we are going to kind of use the conclusion, the hypothesis and the conclusion. The hypothesis is a triangle is isosceles. So if it's isosceles, then what can we conclude? Well, here's my picture. It is isosceles. The base angles are congruent. So angle B is across from a 2 tick mark side, and angle C is across from a side that is the same lengths, which means those 2 angles have to be congruent. So my conclusion, angle B is congruent to angle C. Now, the converse of this statement is true as well. Converse just means, what if we flip the if and then statement around? What if we know a triangle has 2 congruent base angles? If we know the 2 base angles are congruent, because they're the same size, that means the sides across from them have to be the same length. So my conclusion, if B is congruent to C, then I know that AB is congruent to AC, which by definition makes it an isosceles triangle. Okay. Equilateral. We talked about this the other day when we defined equilateral triangles. Equilateral stands for all sides being congruent. But we knew that if it was congruent, since we're across from equal side lengths, each angle is across from the same length of a side. That means that the angles have to be equal. And if it's equilateral, it's also equiangular. Vice versa, if you knew that the angles were equal, then our conclusion is it has to be equilateral. And then we talked about this as well, but remember, if you know that all these are equal, they have to also add up to 180. 180 divided by 3 equal angles tells me each angle is 60 degrees. Quick little note, just by knowing that the angles are congruent doesn't mean that the triangles are congruent. If I have a 60 degree triangle, actually, let me see if I can do this. What if I take this triangle right here and I shrink it, right? Notice the angles didn't change. They're all 60, but these two triangles are clearly not congruent. So just by knowing it's equiangular does not prove that it would be congruent to another triangle. You have to know side, 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 angle, side, any one of the 5 methods that we use to prove triangles are congruent. Okay, how do we solve problems based off of the 2 pieces of information we just learned? We have to really analyze the picture and solve these problems as we go. So pause it for a second, go ahead and draw this, and then if you'd like to, see if you can solve it on your own. All right, I'm going to start here, just looking at this triangle that's highlighted in yellow. Notice it's equiangular. If it's equiangular, it's also equilateral, which means I know this length is 7, and I could put 7 any spot that it has a congruent tick mark, which the side length x has to be 7, and we're done with that side. So what if I take a look at the other triangle and I conclude, notice the angle right here has one little tick mark for the angle and it's got another little mark for the angle. That means angle B is congruent to angle C, which tells me angle B or triangle BDC is isosceles. If it's isosceles, then our conclusion is that it has 2 congruent sides, and the sides that are across from the congruent base angles have to be equal. Well, if this side length is already 7, that means this side length from D to C is 7, which tells me to find y, 7 plus 7 equals y plus 4. Subtract 4, and we get y equals 3. So we found x, we found y, but then they asked me to find the perimeter of ABC, which means I just have to make sure I understand what each side length of the big triangle is looking for. The perimeter of ABC is the side lengths 7, 12, and then this full length, which isn't 7 plus 3, it's 7 plus 7. So I have to add those together. And remember, AC is equal to 7 plus 7, which is 14. And then we can add those. That's 26. 26 plus 7 tells me the perimeter of ABC is 33. All right. Why don't you go ahead and try this one? Pause the video and give it a shot. Okay, let's go through and kind of analyze what we have. We've got a couple things going on here, and notice how there aren't any numbers. You need to make this conclusion, and it's all based off of this triangle to start. Ooh, and that's a nice straight line. What do I know? Well, I've got equilateral. If it's equilateral, it's also equiangular, which means this is a 60, 60, 60 equilateral triangle. So conclusion very quickly, x is equal to 60. But so are the other two angles. And the next thing I'm going to do then is use this fact right here. See this 90-degree mark? That means that the two angles come together to form a 90 degrees. And if this angle is 60, the remaining angle right here has to be 30. So I used that piece of information. And now let's focus on the other triangle right here in yellow. Well, that is an isosceles triangle. We can make that conclusion based off of the two congruent tick marks. And since the 30 degrees is one of the base angles, the other side across from that one tick mark side has to be 30 as well. And then you know that any triangle has to add up to 180. So that's the triangle sum theorem. If I take y plus the two angles that are equal, 30 and 30, you get 60. If I subtract 60 from 180, I get y equals 120. All right, two more, and I'd like to just give a shot. Notice how you have x and y. Find x, find y. Okay, let's take a look. Now you have to be very, very careful with this. We've got two congruent sides, so we have an isosceles triangle. Across from those congruent sides are the congruent base angles, which tells me this angle here is 62 degrees as well. Now it doesn't matter which one you find quickly, that tells me that 62 has to equal 2x plus 1. So if I divide both sides by 2, you could have also distributed the 2 here. It doesn't matter. I like to just divide by 2 to get rid of that. And that just leaves friendlier numbers here. If you subtract 1, x is equal to 30. And then look at y. Y is part of the big triangle, and I know that these two angles are 62, and y plus the two 62s has to add up to 180. That's the triangle sum theorem. So add those angles together. If I subtract, we end up with, oh boy, what is that? That's 54, 56. 56 degrees. And you can always check, plug it back in. 56 plus 124 is 180. All right, last one here on this page. Notice it's a 90-degree isosceles triangle. So that tells us something different. We do know that these two angles are congruent, but I also know that these two angles are congruent and they have to add to 90 each because this one is 90. So 180 minus 90 leaves 90 left for the sum, which tells me both of these two angles have to be equal and add 90, so 45 apiece. And then it's just real quick algebra. So I'll let you guys solve that. Okay, when you solve them, you should have got x equals 28, y equals 29. Last piece, and I'm not sure if you want to write this down or not. This is an interesting proof that we're just going to talk about quick, and it's a little bit challenging here just because we've got a picture, and that picture actually shows multiple triangles, right? You got the 4 triangles that you can see that make up this potential trapezoid, but you also have triangles within that, right? I've got A, B, D, and I've got A, B, C. I also have even bigger triangles, A, C, D. So which ones are we going to use? I recommend highlighting when you need to, but let's look at the given information. And also look at what they're asked to show. We're going to show that CED, CED, we have to show that this length is an isosceles triangle? Well, let's see if you're ready for a proof like this. AD is congruent to CB. So we have one pair of sides already. And then they say angle CAD. So I'm going to follow C up to A, up to D. So that's this angle right here. And then I've got DBC. So DBC, those two angles are congruent. So I have a pair of congruent angles. And then I'm going to really focus on these two triangles right here. Now, if we were doing a two-column proof and really writing this out, we might get in a little bit of trouble because this angle is not technically, it came from the bigger triangle, but this angle here is a congruent angle. And then notice the blue part makes a bow tie, which tells me I have vertical angles. So now I can actually show that angle, or excuse me, triangle AED, that's AED, is congruent to triangle, and then just match the same BEC. And again, I could have renamed this. I could call it DAE or DEA. I would just have to follow the same with the other triangle. But wait a minute. I just showed, or in a sense, proved that the triangles are congruent. Because they're congruent, don't we know that all the other pieces in this triangle are congruent? So I could say that AE is congruent to BE, but what I want to focus on is I want to focus on what do I know from the congruent triangles that helps me answer the fact that this triangle is isosceles. Well, if it's isosceles, and I can show that DE is congruent to CE, look at the statement. ED is congruent to EC. And the reason is corresponding parts of congruent triangles are congruent. Therefore, the little three dots is our symbol. Therefore, we just showed that triangle CED is an isosceles triangle. Okay, here's what you got. Homework tonight. Remember to show your work, draw your pictures, interact with your pictures, and then you're going to submit a image to Schoology. This is in the 4.7 PDF in the link on our Schoology page. Otherwise, you can look at the blank notes and you can get the problems here. Good luck.